Hey there. In today's video, we're going to look at how to solve normal distribution word problems using the z-table, aka the standard normal table. This video is a continuation of my last video on finding probabilities using the z-table, so if you haven't seen that video yet and you don't feel comfortable looking up probabilities using the table, I encourage you to watch that video first. I also made a video on how to solve normal distribution word problems using the TI-84 calculator, so if you're interested, please check that out as well. Alright, so here's the problem we're going to work on. It says, the length of human pregnancies is normally distributed with a mean of 266 days and a standard deviation of 16 days. We know we're working with a normal distribution word problem because it states that the length of human pregnancies is normally distributed. We're given that the population mean is 266 days, so we write mu equals 266, and we also have that the population standard deviation is 16 days. So we denote that as sigma equals 16. Here we're going to let the continuous random variable x represent the length of a randomly selected woman's pregnancy. Our first question is going to be, what is the probability that a pregnancy lasts more than 286 days? Using probability notation, we represent this as the probability that x is greater than 286. Let's start by graphing a normal curve centered at mu equals 266 and label the values on the horizontal scale with 4 standard deviations above and below the mean. Here we're interested in finding the probability that x is greater than 286, so we'll label and draw a boundary at 286 and shade the area to the right of that number. The next step is to standardize 286, or in other words, we're going to convert 286 to a z-score. We do this by using the conversion z equals x minus mu divided by sigma. So here we're going to plug in 286 for x, 266 for mu, and 16 for sigma. Performing this calculation, we get a z-score of 1.25. Finding the probability that x is greater than 286 is equivalent to finding the probability that z is greater than 1.25. Now we can graph the standard normal distribution and label it with the z-score we just found. Our goal is to find the area shaded to the right of 1.25. Using the methods from the previous video, we can now find the probability or area under the curve using the z-table. Since we have a positive z-score, let's pull up the positive section of the z-score table and locate the row with the heading 1.2 in the first column. Then we find the column with the heading 0.05 on the top row. The row and column intersect at 0.89435, and what we just found is the area to the left of 1.25. However, what we're interested in getting is the area to the right of 1.25. Recall that the total area under the curve is 1, so to find the area to the right of 1.25, all we have to do is subtract 0.89435 from 1, and that will give us what we're looking for, which is 0.10565. As a quick reminder, each probability in the body of the z-table represents the cumulative area to the left of the z-score, and that's precisely the reason why we had to subtract the probability we found in the table from 1. We can also show this calculation step by step using the rule of complements. Applying the rule of complements to the probability that z is greater than 1.25, we get 1 minus the probability that z is less than or equal to 1.25, which we found to be 0.89435 just a moment ago. So we subtract this probability from 1 and we get the same answer as before. So the probability that a pregnancy lasts more than 286 days is 0.106 rounded to 3 decimal places. The next question we want to answer is, what is the probability that a pregnancy lasts less than 258 days? Using probability notation, we write this as the probability that x is less than 258. As we did before, let's graph the normal curve and label the x value and boundary at 258. In this case, since we have a probability of the form where x is less than some specific value, we'll shade the area to the left of 258. Now let's go ahead and convert 258 to a z-score using the formula z equals x minus mu divided by sigma. Plugging in the values for x, mu, and sigma, we get 258 minus 266 divided by 6, and that equals negative 0.50. The probability that x is less than 258 is the same as the probability that z is less than negative 0.50. So we graph the standard normal distribution, label it, and shade the region that corresponds to the probability. Here we shade the region to the left of negative 0.50. Since we have a negative z-score, we'll use the negative section of the table. Now let's look for the row with the heading negative 0.5 in the first column. Then find the column with the heading 0.00 on the top row. At the intersection, we'll find the probability that we're looking for, and that's 0.30854. So this is our final answer, which represents the probability that z is less than negative 0.50. In other words, the probability that a pregnancy lasts less than 258 days is 0.30854. For the next question, we're interested in finding the percentage of pregnancies that last between 240 and 285 days. We write this using the following probability notation. As usual, let's graph the normal curve and label the two x values given. Here we shade the area bounded by 240 and 285 to represent the probability that x is between those two values. In this case, we'll have to standardize or convert 240 and 285 to z-scores using the z-score formula. Let's compute the z-score that corresponds to 240 first by plugging in the information. Using a calculator, we get a z-score of negative 1.63 rounded to 2 decimal places. Similarly, applying the z-score formula to 285, we get z equals 1.19. Now we can express the probability that x is between 240 and 285 as the probability that z is between negative 1.63 and 1.19. The graph associated with this probability is shown below. The probability that z is between negative 1.63 and 1.19 is the same as the probability that z is less than 1.19 minus the probability that z is less than negative 1.63. I went into detail on why this is true in my previous video, but basically what we're doing here is first finding the area to the left of 1.19 and then subtracting the area to the left of negative 1.63. And that's what gives us the area between negative 1.63 and 1.19. Alright, so let's look at the positive section of the table and locate the row with the heading 1.1 in the first column, then find the column with the heading 0.09 on the top row. At the intersection, we get a probability of 0.88298, and that's the value we use for our first probability. Now let's use the negative section of the table and look for the row with the heading negative 1.6 and then the column with the heading 0.03. In this case, we get a probability of 0.05155, and this is a value we use for the second probability. Plugging these in, we get 0.88298 minus 0.05155, which gives 0.83143. So, the percentage of pregnancies that last between 240 and 285 days is about 83%. For the last question, we want to find the range of pregnancy lengths which contains the middle 95% of all pregnancies. In this case, we start by graphing the standard normal distribution and shade the middle 95%. Unlike the first three questions where we're asked to find probabilities or areas under the curve, here we're given the area under the curve and our job is to find z-scores first. So now we're doing the reverse process. If we know that the area of the middle region is 95% or 0.95, then how do we find the area of the purple region shown? As we've done before, we subtract 0.95 from 1 and we get that the area of the purple regions is 0.05 or 5%. By symmetry, we can then determine the area of the left tail and the area of the right tail by simply dividing 0.05 by 2. So we get 0.025 for the left tail and the same for the right tail. Now we can find the z-score associated with the left tail given by 0.025, and we can write this as a probability using the following notation. Then we'll need to find the second z-score using the area to the left of it, which is 0.025 plus 0.95, and that equals 0.975. From here, we can use the z-table to get both scores, so let's do that right now. First, let's look up 0.025 using the negative section of the table. We'll scan the body of the table to find the probability closest to 0.025. Here it is, and this corresponds to a z-score of negative 1.96. Now let's look up 0.975 using the positive section of the table. So we'll scan the body of the table again and locate a probability closest to 0.975. Let's circle it, and the z-score is positive 1.96. Let's label the graph using the two z-scores we just found. Notice that the z-scores that we just found are the same but opposite in sign, and that's because of the symmetry of the standard normal distribution. So we could save some time here if we use symmetry by looking up only either 0.025 or 0.975. The next step is to convert the two z-scores we found to x values representing pregnancy lengths. To do this, we'll need to solve the z-score formula for x. First, we multiply both sides of the equation by sigma to get sigma times c equals x minus mu. Then we add mu to both sides of the equation, and from that we get mu plus sigma times z equals x. Finally, we rewrite the formula as x equals mu plus sigma times z. Alright, so let's apply this formula to get our x values. Using the formula for the negative z-score first, we get 266 plus 16 times negative 1.96, and that equals 234.6. Doing the same thing for the other z-score, we get 266 plus 16 times positive 1.96, and we get 297.4. Therefore, the middle 95% of all pregnancies last approximately between 234 and 298 days. Alright, that should do it for today. I hope this helps, and I'll see you next time.